Let's do our notes for geometry, chapter 10, section 5. We're going to be talking about other angle relationships. Still with circles, of course, in chapter 10. If a tangent and a chord, think in your mind what that is, intersect on a circle. Pause it if you need to write all this down. If a tangent and a chord intersect on a circle, then the measure of each angle is half the intercepted arc. The measure of each angle is half the intercepted arc. So this time, compared to in your previous section, this time your tangent and your chord are meeting on the circle. Here's your tangent, here's your chord. The measure of each angle is half of its arc. Where is its arc? It's right where the chord ends and where the tangent hits. It happens to make this arc right here. Angle 1 goes with that. But it also makes a major arc over here. When you have a chord and a tangent that intersect, you actually end up making a minor and a major arc. So the measure of angle 1, right down here in this corner, is equal to half, here's the angle, it's equal to half of its arc, the measure of arc AB. But the red angle, angle 2, is half the measure. So here's angle 2, and angle 2 actually goes all the way like this. It's half of the measure, and now we have major arc A to C to B. Think of that. If I took arc AB, no matter how big it was, and added it to arc CBA, that'd be 360 degrees altogether. But this is going to be half of that arc, and this is going to be half of that arc. What happens when you cut 360 in half? You only get 180 degrees for these two angles. Aha! Aha! Take a look. How big are angle 1 and angle 2 going to be? You put them together, they're 180 degrees. Let's go back to semester 1 on our linear pair. There's a linear pair. Again, make sure you're looking at the angle, not stopping it where the arc stops. Let's try a couple of those. Here you've got a circle. You're going to have to pause it if you need to draw it. Tangent line AC, and you have a chord BD, and you have an arc measure up there of 210 degrees. The measure of angle ABD, let's get good at how we name angles again. A, B, D. If this is 210 degrees, let's cut that in half and make it 105 degrees. How big is the measure of angle CBD? Well, it's half as big as this arc is. We know there's 360 degrees in a circle, so there's 150 degrees left over right there. Half of 150 is 75 degrees. And I know, you guys like to do stuff in your head. So right now you're like, well, couldn't I have just taken 180 minus 105? Sure, you could have. Assuming you got this angle right. If this angle was correct, this angle will be correct when you subtract. If this angle's wrong, you're going to screw up that angle also. So be careful. You've heard me talk about that before. Let's try this one. Different diagram. Draw it if you have to. Now we know how big the angle is this time. We know that this angle from F to G to K is 80 degrees. How big is the measure of the angle from H to G to K? H to G to K, they're a linear pair. They have to add up to 180, 100 degrees. Don't forget your degree symbol. But how big is the measure of arc GK? Minor arc, start at G, end at K. It's minor, so you know you have to go this direction. If that was 80 and it was half of what this is, we're going to have to double it to get the full arc of 160 degrees. Want to check your answer? How big would this arc be from G to something to K? That's a 200 degree arc. 100 times 2 is 200. What's 200 plus 160? 360. So you can check your answer on that. Next one. If two chords intersect inside a circle, then the measure of each angle is half the sum of the measure of the arcs intercepted by the angle and its vertical angle. Holy cow. Maybe pause it and write this down and then listen to me read it and we'll try to see if it makes sense. Or look at a picture. Sometimes a picture helps. So pause it and write it down. All right, unpause. If two chords intersect inside a circle, so they're basically going to cross inside the circle, then the measure of each angle is half each angle. Talking about the angles, not the arc. And you have to cut it in half. Half the sum, so we're going to do a little adding, of the measures of the arcs intercepted by the angle and its vertical angle. All right, let's take a look at the picture. So there's two chords intersecting inside the angle. That's not so bad. They intersect right here. The measure of an angle is half of the sum, we're going to put the sum in parentheses, of the arcs intercepted by the angle. So here's this angle. We're looking for x. It's half of the arc intercepted by its angle, 156 degrees. Ooh, I need bigger parentheses. And the sum of that and its vertical angle. Well, where is x's vertical angle? It's right here. Probably should have called that another x. There's the vertical angle. The sum of its arc and its vertical angle's arc. So you're basically going to add 130 plus 156 and cut it in half. Half of 286. Cut that in half. You find out that x is 143 degrees. And if x is 143 degrees, so it's its vertical angle. And if you really wanted to, you don't have to, but if you really wanted to, you could find these angles, because those are linear pairs, just like they were first semester. We don't change that. Let's try it with this one. Pause it to draw it if you need to. Wants to know how big the measure of angle 1 is. Measure of angle 1 is half of its two arcs, 40 plus 96. So half of 136 equals 68 degrees. Don't forget your degree symbol. How big is the measure of angle 2? Measure of angle 2 is 180 minus 68, which equals about 112 degrees. How did I know it added up to 180? Because they're a linear pair. Right there. I don't need to know how big those arcs are. I just need to know how big angle 1 is. Try another one. They give you that little, oh, this one's backwards. They gave us the angle. We have to come up with the size of the arc. We want to know how in the world, how big is this arc DC? Well, we can do the formula, and we can do algebra, and we can solve equations, so let's put it all together. If I know that the measure of this angle, 62.5, I know the angle is half of whatever 50 plus x was. I don't know x, but I know everything else. So you work the problem backwards. I'm not going to distribute that 1/2 because I don't want to work with a fraction. You can if you want to. I'm instead going to multiply by 2 to get rid of the fraction. If you do that on one side of the equation, you have to do that on the other side of the equation. And if you do that, you get 125, I hope. 125 equals 50 plus x minus your 50 over to the other side. That should be a 75-degree angle. 75 equals x because that's the way we did the algebra. But we have the measure of arc DC, and the measure of arc DC is 75 degrees. But there's more. What if those two chords don't intersect inside the circle? What if they intersect outside a circle? If two lines intersect outside a circle, then the measure of the angle formed is half, here we go again, half the, doesn't say sum, it says difference. We're subtracting. Half the difference of the intercepted arcs. So what does it look like when the two lines intersect outside of the circle, or in this case they're segments, but they're pieces of lines? If the two lines intersect outside of the circles, and they tell you that the measure of arc AE is 100 degrees, the measure of arc BD is 30 degrees. Oops, I probably should have put that on the other side. Won't let me. Measure of angle C equals half the difference. I don't know whoever figured that out, but it's kind of cool that they figured it out. Works every time. Take 100 minus 30, get 70, cut it in half. Half of 70 is 35. They somehow figured out that when they're outside of the two arcs, you subtract them and cut it in half. When it's inside the two arcs, you add them and cut them in half. You just got to remember which is which. Oh boy. Do yourself a favor. Pause this, draw it, get it all set up. See if you can find x on your own. They're telling you up here that the measure from A to B is the same as D to E. Those are the same size. All right, go. Okay, you're back. Let's see if you found it. If arc AB, chord AB is the same size as chord DE, those are congruent chords. Congruent chords cut off the same size arc. So if that's 52, then that is 52. We know that altogether there are 360 degrees in a circle. So if there's got to be 368 altogether, and you have to take away 52, 178, and 52 again, you're going to end up with 78 degrees left over for that little arc from B to D. Double check my math if you need to. Add them all up, it should be 360. How do you find x? The measure of an angle, if it's outside, is half the difference of the two angles. Half of 100 is 50. And notice I just put x equals 50. It didn't say find the measure of angle C and put 50 degrees. It just said find x. It's just a variable. 50. That's it. Good luck practicing some of those in your assignment.